Okay. All right, so again, we're on normal curves, picking up from yesterday, and we're going to look at example 5. The number of M&Ms actually in the standard package is normally distributed, okay? So I said, as you're reading these, the statistic questions, they get wordy. So we want to highlight this word normal every time we see it. Okay, they're normally distributed with a mean of 55 and a standard deviation of 3. What percentage of the bags contain between 49 and 61 M&Ms? So let's go ahead and draw out your normal curve, just like we did yesterday. What number always goes in the middle? The mean, good. So I'm going to put my mean of 55. And our standard deviation is 3. So we're counting out by 3, and we put a total of 3 standard deviations in. So fill out your curve, just like we did. Mean goes in the middle. Write out your 3 standard deviations from the mean. So what's that get me at 52 times 6? Okay, so the question says, what percentage of bags contain between 49 and 61? So once you've drawn your curve out, go ahead and just mark it on there, 49 and 61, and this should be a super friendly one. How many standard deviations am I going above and below the mean? 2, and that's a number we should have memorized. How approximately is what 2 standard deviations? What percentage? 95. Okay, so I should know this is approximately 95%. Okay. Now, remember, they're not going to give you this distribution on the exam, so that's what I'm saying. We've got to memorize. We said 1 standard deviation is 68, 2 is 95, 3 is 99. 3 is almost everything, remember, except those little 0.1s on the end. Okay, it's almost everything. And again, approximately there was some decimal with it. Part B says, if you bought 125 bags, how many of them would you expect to have less than 52 M&Ms? Okay, so now what should I be finding on my curve? 50, 52. And where am I shading if I say less than 52? To the left, the numbers that are less than 52. Okay, now 52 is how many standard deviations away? 1 below. So flip back to your main page there. Go 1 below, and then you need to add up all the percentages to the left. So use your calculator, add up all those percentages to the left. That's not a number you've memorized. Okay. The only ones we have to know are 68, 95, 99. Add up your percentages to the left. What percent are we getting? 15.9%. Now, that does not answer the question. Just to be clear, that's not the answer to the question. It says, if you bought 125 bags, how many of them would you expect to have less than 52? Well, we would expect 15.9% of them, and now I have to figure out how many bags that is. That's 0.159 times 125 bags. So approximately how many bags is that? 22? 20? Sorry, does 20 sound right? Okay, so again, just an approximation. All right, so our main goal was understanding the 68, 95, 99. All right, take a minute, and on the homework page, we're going to go do number 5. All right, so we did 1 through 4 for homework yesterday. Go tackle number 5. So get it drawn out. Okay, with whatever mean and standard deviation they give you.
Mark that down.
I'm going to mark that down. So 9 to 15, I think, was super nice. That was just one standard deviation away. So we didn't even have to add that. Hopefully you got 68% just knowing one standard deviation. Between 12 and 15, what did we get approximately? 34%. 6 or less, 2.3%. And 15 or more, 15.9%. Is there anybody who missed one of those that needs an explanation? Owen, you good? Ryan? This guy here? So our mean was 12, and we want 12 to 15. So that's just from the mean and up one standard deviation. So I'm just adding, basically it's half of the full standard deviation, because the full goes below and above one.
Yeah, I just did 19.92.
Oh, but I think that's a half. Yes. So just make sure you go out to 1. Yep. No problem, Griff. No problem. All right. Now, I keep saying they're not going to give you this distribution, right? So there's got to be another trick here. All right. Now, the one thing you can't avoid is the 68, 95, 99. We have to know 1, 2, and 3 standard deviations. But there is a little trick. So we're going to go back to the front of this page. All right, right at the top of your notes here. And there's a button on the calculator that will help you. But obviously, if you didn't draw it out and know where it came from, it wouldn't make sense just to plug random things in a calculator. So there is a button called Norm CDF. And I have honestly no idea what CDF stands for. Griff, take your phone out real quick. Type in Norm CDF and tell us what this means. I know this is the button, but I don't actually know what it stands for. Cumulative density frequency is my guess. Yeah, I have no idea. What does Norm CDF stand for? We just predicted that. You can't find it?
Not coming up with definition.
Well, you gotta look up on the T84.
It's not coming up.
Come on, Griff, I give you one job.
Oh, I got it. Cumulative distribution function.
Cumulative distribution function?
Yes.
All right. That's what it stands for. Cumulative, I was close. What did I say, density something? Cumulative distribution function, which makes sense. It is a distribution. So it stands for cumulative distribution function. Now, you'll notice when we find this, there's a PDF and a CDF. Just like we only use one variable stats, this is the only one we use. Oh, density function.
I got a distribution.
Mm-hmm. Are you just making that up?
No.
It actually said that?
Maybe I'm picking on
Normal cumulative distribution function.
Distribution does make sense because it is a
Doesn't
normal
make it
distribution.
Okay, well, I just looked up.
She was on my side, that's all that matters.
Exactly.
Normal CDF. Well, whatever works around here. So you'll notice that there's a PDF and a CDF. We only use CDF, okay? So we're never gonna have to guess. You're always gonna pick CDF. Now, where you find this is probably hidden. So find under. You're gonna have to hit second, so I'm gonna put it in a box. And I think you have to hit distribution, which would make sense. I should have picked distribution instead of density. That would make sense. Second distribution. Okay, so we're going to go through and we're going to do the exact same problem we just did. What was that? Number 5, using the calculator. Okay, so you're going to find this under second distribution, and we're looking for norm CDF. So flip back to question 5. We're going to practice typing all these in with the calculator now. Okay. All right, so distribution looks like it's by the arrows here on the vars key. All right, so I'm going to hit second distribution. All right, do you notice how I said there's a couple norms here? You're always picking CDF. You don't have to guess, it's CDF. All right, the lower bound would be your lower number. So in option or question A here, my lower bound is the 9. My upper bound is 15. Okay. This is a population mean, this symbol here. All right, so this is your mean, and obviously that's your standard deviation. What did they say the mean was? 12, and the standard deviation is 3. So you're literally just going to type those in. You're going to hit paste. Probably have to hit enter again. And hopefully it spits out that same percent we had. Okay, let's try the next one. Do it again. Second distribution. It's always norm CDF. Okay, we're going between 12 and 15. Mean of 12, standard deviation of 3. 34%, that's what we had, so it's working out so far. Now here's where it gets goofy, okay, because we don't have necessarily a min and a max, right? If I just say 6 or less. So let's make a note here back where we wrote this down. When you're going down forever, you want it like, you want to try to put like infinity in there, because you want to say you're going down forever, like negative infinity. So the closest way to say that is to write negative 99999. Bunch of nines. And if you were going up forever, in theory, you'd want to say positive infinity. So if you want to go up, you would put positive 99999 in one of those. Okay, so if you're going up or down forever, you're going to use, there's no infinity button, so we're just going to go negative 99999, positive 99999. Okay, so let's try typing in 6C here. So pull up our second distribution, norm CDF. Okay, now if I want 6 or less, is 6 my upper or my lower? 6 is my upper, so my lower is negative 99999. And a 6 for my max. And then paste. And did we get the same percentage? 2 point, if I round that, 2.3. And then let's try 15 or more. So second distribution. 15 or more means my lower is going to be 15 and I want to go up forever. So I'm going to go 15 now for my lower and 99999 for my upper. And I should get that 15.9%. Okay, so again, you see, the calculator is useful, but you got to know how to use it at the same time here. Sorry. All right, so does it make sense that you can really use this to answer all these normal distribution questions? So again, you still have to know 68, 95, 99, and I'll lead into that in a few minutes on where we use it again, but they're still very important. So let's flip the page, and on the practice, go ahead and do 9. Okay, and now that you have the calculator tool, you are welcome to do it on the calculator, and I'm going to encourage you to do it on the calculator because you don't have that picture for you on the exam. But go ahead, read 9 to yourself and answer A and B. Bless you. confused, Shane. What can we help you with? Starting. Are we just talking math, or are we?
Yes. Why are they the same? Should they not
Why are they the same? I think it makes sense because this was 2 below and this was 2 above. So I think visually it should make sense.
I didn't get there yet. Times 8,000.
So I'm getting, let me know if you agree here, I got 2.275%, whatever, perhaps you rounded to 2.3.
That's what I did.
We okay for that? That's fine, that's fine.
Yeah, I got 180.
And then to figure out the cars, I'm going to go 105 or above, which did turn out to be the same percent, 0.02275. But then I had to figure out how many cars, so we're not done there. I still have to now multiply that by 8,000 cars. And that's approximately 100 and, oh shucks, I got 2.
182.
So I just took that whole decimal because it didn't say round. I just used that whole decimal and hit times 1,000. Did you round your previous, would you leave it as point?
I left that as like 0.023.
23 times the 8,000? Yeah, so I guess, so that does change your answer, so just be careful. If it doesn't say round in the middle of the problem, make sure you use that full decimal.
All right.
Okay, does that make sense? All right. I'm gonna do that for 1 second. So I just grabbed a Regents exam, the January one, just to, oh shoot, and I think I wrote in this one, so don't look at my answer. Cover this up. All right, here we go. So this is the question that was, sorry, I'll try to zoom in here in a second. I'll read it out loud as well. So this was a question 29, so it's a 2-point question. It's short answer. So you have to have some work, I guess, is one of my main points here. The heights of the member of a ski club are normally distributed. This is, do you see how this word normal's here?
Yep.
And it's called normal CDF. The moment you see this, you know it's a normal CDF question. Does that make sense? Normal CDF. I'm saying when you see the word normal, you're going to use normal CDF. All right, make a little note someplace on the bottom of that paper. The average height is 64.7. So the average, aka the what? Mean is 64.7. Jot it down, Shane. The standard deviation is 4.3 inches, 4.3. Determine the percentage of club members to the nearest percent, so now they're asking you to round your answer, who are between 67 and 72 inches tall. All right, go for it. We'll put 1 minute on the clock, starting now.
1 minute?
1 minute.
That's not enough time.
Well, I bet I can do it in 15 seconds,
This is
so.
at least a 90-second question.
No.
That's why this is North CDF.
Yeah, that's a great idea.
I don't even know what that means.
Well, you can ask Griff, he's all over this.
You got it wrong.
What do you mean I got it wrong? I didn't do nothing.
Oh, it's not letting you do it.
What are we getting for an answer? 25%. Now, here's our only problem. If you just write 25% down, we can't give you the full credit because this is the what section? The short answer section. You have to have something down there. Okay, so probably the easiest thing to do is literally make sure on the exam you write norm CDF. You can tell the grader that's fine. And then just write down what you used. What do we put in first? The lower, so it would be 67 to 72, the mean, and then 4.3. There has to be something there and the answer. If you only wrote the answer, the rubric says we can only give you 1 point. No matter how many points it's worth, it's 1 point only. Okay, so the answer means nothing without the work. That's perfect. You just got to have something down there to back it up, okay?
You said an Air Force Davis?
Probably not. Give me a little more than that. All right. Yes. Pretty much write it down. All right, I'm going to switch gears on you, so go back to your book. And I just want to stress something here. Turn to Z-scores. All right, now I'm going to skip around a little bit today. I did go through a lot of the stats questions, and I did not see a single question on Z-scores. So I'm not going to spend a ton of time on Z-scores. I'm going to talk about it, this little example here, and then I'm going to review all the questions again and see if there's really anything on z-scores, because I don't want to waste my time on them. Number 1. There are 400 juniors in Hilton that took the ACTs a few months back, and the results were just released to the school. The scores were, there's that key word, normally distributed. Highlight. Okay? So in my head, I'm saying this is probably a norm CDF type problem. With a mean of 24, so label that on your picture. Where does the mean fall? Right in the middle. And a standard deviation of 4. So finish labeling the rest of our curve. Our standard deviation is 4. Our spread is 4. All right, let's see if we can answer 1 or 2 of these without a norm CDF. How many fell between 20 and 28? Should we know that answer? 68%, because it's how many standard deviations? 1. So we should know that's approximately 68%. Okay. 16 to 32, should we know that answer? Yes, 2 standard deviations is 95%. 16 to 28, should you know that answer? No. That's down 2, but only up 1. So now I can do a quick norm CDF. So throw those in your machine here. I like to call this a little plug and chug, Griff. No, I'm going to keep saying it. A little machine.
82%.
Approximately 82% I hear. Less than 12. So again, that's definitely not one I'm memorizing. That's norm CDF. Less than 12. So would 12 be my max or my min? Max.
Alright, you get it, you answered it fast.
So 0.13, I'm going to put a couple decimals there, 0.134%. And then greater than 24. 24 would be my min. %. All right. I'm only going to do 2 of these because only 2 of them match up here maybe. Looking at this side, now it says not what percentage, but it says how many juniors. So let's do the ones that match up. Let's do 20 to 28. So we already know 20 to 28 is what percent? 0.68. And now if I want to find the number of juniors, I'm just going to multiply that by 400 juniors. Okay, and this will tell me how many people. 272. Is there another one we know on here? Does any other one match up? Higher than, I don't think that matches with another one. I don't think the others match. Do we get the idea on how to do this? I don't need to recalculate these, do I? We're good? Okay. Now, I'm going to do something a little weird. I'm going to try to superimpose another graph on top of this one. Okay, so here's what I'm going to do. I'm going to say the mean is still 24, but now the standard deviation is 2. So think about what should happen. If right now my standard deviation is 4. If my standard deviation gets smaller, what should the data do? It should get closer to the mean. And that's the whole point. That's what we talked about yesterday. When the standard deviation shrinks, it should get closer to the mean. So watch this. So if we're at 24, if I'm going a standard deviation now, I should get a 26, then a 28, and then a 30. That should be my max. If I go down, that should be a 22, a 20, and an 18. So what's going to happen is the spread is going to it's going to come in. It's going to be much more tight, and the max is probably going to shoot up a little more, something like this. But do you see how that standard deviation, when it shrunk, it kind of compressed towards the mean? Okay, and that was one of our big goals yesterday. When the standard deviation gets smaller, we're going to have a tighter, our data will be closer to the mean. And likewise, if my standard deviation got bigger, let's say our standard deviation is now 8. What should happen to my curve? It should spread out a lot further. So I'm just going to, I don't have another, you got another color? Is that a highlighter? Can I use this? Thanks. All right, so I'm going to say, here's my first one is 24. What would my next number be? 24 plus 8 would be 32. Then it would go out to 40 and 48. If I subtracted 8, I would get 16, then 8, then 0. So this curve would look more like this. Whoops, that's terrible. Sorry. But you get the idea that spread, thank you, it's way further spread out. And that's, you know, there's not a lot of good data I'm going to read from that if my standard deviation is so far apart, okay? So I just wanted to review that. All right, so I'm really switching gears on you. Flip the page again to, what's the next thing? Margin of error. We're moving today. Okay. Margin of error. In stats, we attempt to infer characteristics about a population from a sample. Because remember, it's really hard to get your hands on an entire population. So we use these samples to make inferences about a population. However, these inferences have a degree of uncertainty. Okay, so what that uncertainty is, we call a margin of error. This is the measure of how accurate we believe our sample statistic to be relative to the population. Okay, so I don't know if you're into politics, and when they start doing all the elections, you'll see, you know, Trump's percentage of whatever is given at the top of the screen, but then there's always a margin of error next to it. They'll tell you, we don't really know if it's that, but it falls within this interval, is our margin of error. Recall the normal distribution of the sample means has 95% of the sample mean within how many standard deviations? 2, good. 95 is 2 standard deviations because we had to memorize 68, 95, 99. Okay, so we've got 2 methods to find the margin of error. I'm going to focus on the super easy one today, which is this guy here. Multiplying the standard deviation by 2. We're going to tackle margin of error tomorrow as well, but today we're focusing on multiplying the standard deviation by 2. Okay, so we've got example 1. A computer simulator was conducted with a sample size of 80 coin flips. A total of 40 samples were taken. So 40 times they flipped this coin 80 times. Does that make sense? So they flipped the coin 80 times, and there was 40 different times they did that. The resulting is the proportion of heads are shown in the dot plot to the right. For the sampling distribution, the mean is 0.508, and the standard deviation is 0.061. I have a feeling your graph is super blurry. Is that true? Okay, so these dots here, just jot it for yourself. Start at 0.4, then 0.45, 0.5, 0.55, 0.6, 1.65. Okay. So is a sample proportion of 0.55 a likely result? So let's mark the mean. They said the mean is 0.508. So remember, you always want to label the mean. So our mean is roughly here, right? Do you think getting a 0.55 is likely? Is it? And what would be our reasoning? It's close to the mean. So I'm going to say yes. And in my head, I'm thinking it's close to the mean. Because remember, you have more area under the curve the closer you are to the mean. There's more room there. Is getting a sample of 0.38 likely? Is this a likely sample down here? No, why? Yeah, I'm going to say it's farther from the mean. Okay, so a very common question is just to flat come out and do it, find the margin of error. So you really just have to know the formula. The formula says the margin of error can be found by multiplying the standard deviation by 2. So it's literally 2 times the standard deviation. So I'm going to say 2 times the standard deviation. And they came out and told us the standard deviation, so it's 2 times 0.061 I'm getting 0.122. Okay. So again, what is that measuring? It's measuring how accurate we believe our statistic to be. Now, I'm going to come back to that in a second. The next big thing is this confidence interval, and you are probably asked to write a confidence interval at least on every exam. The confidence interval is the range of values that are, so we're going to find a range. A range of values that are likely results is known as the confidence interval. The confidence interval contains 95% of the scores, okay, AKA the margin of error. What we just found. Okay, so here's how we find it. I'm going to go back to this example, and I'm going to write my confidence interval. So flip back here, and we're going to go confidence interval. Okay, so the confidence interval is 95% of the data. That means you take your mean plus 2 standard deviations and your mean minus 2 standard deviations. And we literally did that on day 1. We added 2 standard deviations and we subtracted it. Now, 2 standard deviations now has another name called the margin of error. And we already found that number in part C here. So I'm going to take my mean, which is 0.508, and I'm going to add my margin of error, which is 2 standard deviations. And I'm going to take my mean, and I'm going to subtract 2 standard deviations, aka the margin of error. They mean the same thing. And we're going to find that range. So plug those in your calculator to get a range. So I'm getting a range from just 0.386 sound right for the min one, and 0.63 for the max one. So again, I just took my mean and I added my 2 standard deviations, called the margin of error, and I took my mean and I subtracted it. And I'm basically saying this is my confidence interval. Anything that falls in here is likely to happen. Let's make a note. That means it's likely to happen. Anything that falls outside is pretty unlikely to happen. Because if it's happening 95% of the time, how many times is it not happening? 5%. And that's a really unlikely number. Like, it's probably not going to happen if it's happening only 5%. So if I look at this, does 0.55 fall within my confidence interval? Yes. So that is likely to happen. 0.38 actually falls just outside by a hair, right, on that confidence interval, so it is not likely to happen. It did not fall within this confidence interval. All right. Example 2. As of December 30th, 2015, the New York Knicks record was 15-18. What proportion of the games had the Knicks won at this point in the season to the nearest hundredth? So write out the proportion of wins they have. How many out of how many games? $15 out of 33, and it said to the nearest hundredth would be 0.45. Okay, so obviously that's their win-loss record. They've won 15 out of 33 games. All right, before the season, your friend who is a Knicks fan stated that the Knicks had a 65% chance of winning their games this season. To test this theory against the Knicks' current record, you run a simulation based on the assumption that the Knicks have a 65% chance of winning the games. Each dot plot below represents the proportion of games the Knicks would win. Each has a sample size of 33. All right, can you read these numbers on yours? Okay. Where this little mark is 0.65. And then it goes 0.7, 0.75, 0.8, 0.85, then ends at 0.9. And obviously goes down the other way as well. Okay, so just looking at this, what would we estimate the mean to be? 0.65 about? Sounds good. Okay, and again, it's an estimate. We're ballparking it, right? But we're definitely picking a number in the middle. Estimate the confidence interval that contains 95% of the sample distribution. So where do you think 95% falls? Clearly, it's not this entire thing. That would be what percent? 100%. So where do you think, let's get a range, from where to where do we think, and again, we're estimating, there's no wrong answer, well, there could be a wrong answer, but ballpark it. Where do you think 95% falls? Point what to point what? You're saying, I heard a 0.45 to point, what did you say, 85? All right, we'll go with it. So we're ballparking, that's about 95% of the data. Okay. Based on our estimate, so based off this, estimate the mean and the confidence interval. Based on your estimated mean and confidence interval, what is the margin of error? Okay, so again, the margin of error is how many standard deviations? 2. So if this is the mean, and this is my confidence interval, which is 95%, I'm just looking for the difference from here to here. So 0.85 minus 0.65 would give us a margin of error of approximately 0.2.
So like, wouldn't the standard deviation be 0.5, so then wouldn't it be like plus or minus 0.10?
No. The standard deviation is not the number in between each of these. This was just the simulated results.
So what's the standard deviation?
We don't know yet. We're just ballparking. Now we could kind of guess if we divide this in half. If we take 0.2 and cut that in half, we could ballpark it to be 0.1. We're just ballparking. Part E says the actual mean is 0.658, and the actual standard deviation is 0.093. Okay, we're going to use this to find a confidence interval. So let's first get the margin of error. The margin of error is 2 times the standard deviation of 0.093. 2 times 0.093 is going to get us 0.186. Okay, so now I'm just going to go below. I need my confidence interval. So I need the mean plus my 2 standard deviations or margin of error, and then my mean minus the margin of error, my 2 standard deviations. So I have 0.658 plus 0.186. And 0.658 minus 0.186. So I'm getting from 0.472 to 0.844. Okay, so you always are going to find a confidence interval. Now it says, does the Knicks record claim that they will win, 65% of their games this season? So is it supported by this? Where does 65% fall? In the interval. So does it support it? Yes. 0.65 falls within the confidence interval. Okay. So again, this is just our first half of this. We're going to pick up with margin of error again tomorrow, maybe a little quiz for fun. You know, it's Friday, why not? Have a great day. No extra homework assignment. I think